All right, moving on now. The real test I think that we all need to do to make sure that our definition really is working properly, right? For universal applications, we want it to be able to apply to almost any surface that we want to apply it to, is to go all the way back to the beginning input, right? So our initial input values and start to determine how do we want it to operate. So in this case, I have a surface reference, and I have the number of subdivided panels that it creates on that surface. Right now it's pretty simple. Those are the only ones I have. So I need to make sure that it will modify with that. So as I'm looking at my definition here, if I increase my U count and the triangles are the same, are working, well then it's a working definition, but it looks like it's not. Oops, I think I might have crashed myself here. Hang on. I did not mean to jump it up that high. Hang on. Go back down to 2. Again, that is also not expected. I think it might have to do with our loft settings. I don't think it's anything wrong with the way we developed this. So refit might not be the option we want. Let me just try one more thing to make sure that it works for us before I move on to a different option. So developable loft options. We'll go with refit. We'll change the tolerance to 1. Go here, loft options. Oops. Yeah, so I'm pretty sure it's the settings, just based on the fact that when I changed the refit setting, it basically kind of gave me a change, but it wasn't the right change. So I think at this point, rather than trying to deal with that particular way of lofting it, I'd rather go down a different path. And so, oh, where'd it go? There we go. So I'm going to just quickly take these items here, right, these ones that I built off of to create this, and I'm just going to group them, put a color on it, and make it basically read as if it's not working. So I'll go to color, and I'll just change this hue to a red hue, so I know that that one's not working. And then I'm going to go back up to our other option, which was to use the Srf4pt. So using Srf4pt, it functions very similarly. Actually, let me go and change this back to a 2. Actually, yours looked like it was working with more subdivisions.
I have 4 and 3.
4 and 3? Let me see. I mean, that's not necessarily going to match mine, but I do want to. What did you use exactly the same loft options that I did?
Yeah.
Interesting. Your surface must be much larger or something. Are you working in feet or millimeters? All right, well, we can troubleshoot that all day long. But when you guys are in a bit of a design pinch, you need some versatility, okay? So let's say you get yourself into a pickle like this, like I happen to be in right now. I'm fairly certain I can reasonably do it using a 3-point method in about the same amount of time. So I'm going to try going down that path first before exhausting myself on loft. So also, actually, I'll worry about that later. I could try ruled surface as well. You guys could try that one. But so 4-point surface is going to ask for at least 3 points. So it'll have a first corner, a second corner, and a third corner. This one is going to look a little bit simpler because each one is an individual input. So really what I need is a list item. So under set list, I'm going to grab a list item. And I'm going to use the vertices output here. So I'm going to plug V into my L. You'll see here it's actually generating one in the top left corner. So the default value for list item is 0, so that just basically means my 0 value right here, 0, is in the top left corner. So I'll just plug this in, oops, to this list item right there. Now, that is the first value that I need, but if I copy and paste this and create 4 list items, I'm going to have a 0, a 1, and a 2, and a 3. So now, looking over in the Rhino side, you can see that there are points everywhere, but be aware that this list item is only grabbing the top left corner point of all of those panels. You can't really see it right now because the rest are overlaid on top of it, but this one is grabbing the bottom left. You can see them starting to show up here. This one is grabbing the bottom right, and this one is grabbing the top right. Does that make sense to you all? Yeah? Okay. So simply put, if I want to create a triangle from the top left, and bottom right, then I need to use points 0, 1, and 2. And so I just plug those into the ABC input of Srf4pt. So I'll go just really quick, 1, 2, and 3, or 0, 1, 2, I should say. And easily enough, I can go back to surface, back to freeform, and I can grab another 4-point surface right here. And instead, I just use the 3 other points, which are going to be 1, 2, and 3. Oh, whoops, sorry. It's going to be, that was 0, 1, and 2. So I'm going to use 2, 3, and 0. My mistake. So it'll be 2, 3, and 0. Like that. There you go. So you can kind of see the faceted nature of that triangulation. Yes?
After the, can you just repeat the last 2 steps?
Yeah, it'll be easier to explain it a little bit more clearly when I show the points list, right? That'll be helpful. So I'm going to go to display and vector and point list. Don't ask me why it's under vector. It's a little odd to me. But anyway, I'm going to plug the vertices in and just drop a slider on it real quick to make the text a little bigger. There we go. All right, so studying this top right panel, you can see the letters in blue. Okay, so we have 0, 1, 2, and 3. Okay, that's off of my warped panel, this one right here, the original. Okay. So when I triangulate the first one, you can see that that's going from points 0, 1, and 2. From 0 to 1 to 2. Now the second one, I need to make it go 2, 3, and 0 instead of 1, 2, 3. Did that clarify enough?
So, sorry, another question. So instead of 0, 1, 2, 3, if I put 1, 2, 3, 4, it shouldn't make a difference, should it?
If you do 1, 2, 3, 4, you're going to get another warped surface. You're basically recreating the surface that was already there. Does that make sense? So see how this is still a warped surface? See how it still has a curved side? It's basically just reconstructing what you had built before, rather than actually drawing a line in between it, right? Actually creating an edge in between these where you can actually get a differentiation, right? So this is now actually flat and triangulated. See that? Is that clear? Okay. Any other questions? All right, so now back to the real test then, the one that we just did. So go all the way back to the way we want to use it and start changing our subdivisions and see if it still works. But I think what I want to do is take these two list items and I'm going to disable them so that they don't calculate. Okay, so I'm going to grab these two list items. I'm going to middle mouse click button and I'm going to do this right here. I'm going to turn them on, disable. So now those turn orange because they're not getting any more information because the list item isn't calculating. Does that make sense? I haven't used that yet, but it's something you need to know. So I'm going to go back here now and essentially just start changing the subdivisions. So if I go up to 5, I can see that it is further subdividing it. And I'll change these. Now once you get to a point where it's like heavily triangulated, you're basically reconstructing that surface that you already had anyway. So keeping the numbers kind of down is going to help. Maybe more vertical subdivisions but less horizontal subdivisions will really help to see the faceted triangulations. Okay?
Can you just move the grasshopper all the way?
Yes, it will. Stop this, we'll get you all caught up, and then we'll move on to the next component.